water repellency, water resistance and spread wing postures. The first effort to correlate the value of the parameter, R+D/R, that is, the balance between water repellency and resistance to water penetration, with behavioral patterns was made almost 50 years ago. In that paper, the well-known habit of cormorants of spreading their wings to the sun or breeze after a period in the water, a feature commonly referred to as wing drying, was proposed to follow from the poor water repellency of their breast feathers, as evidenced by their low value for R+D/R in comparison to that for the mallard, Anas platyrhynchus, and presumably other dabblers that do not spread their wings. Only 4 species of cormorants and 1 species of anhinga had been examined with little attention paid to the important differences in the water-repellent structures between contour feathers and flight feathers. In addition, no systematic comparison was made with other water bird species that do not show spread wing behavior, such as the penguins and divers, Gaviidae. In spite of these limitations, the conclusion that the poor water repellency of the cormorant's breast feathers is the proximate cause of its characteristic habit of wing spreading has been generally accepted in the ornithological literature. Since then, further studies on the wing drying of cormorants have overwhelmingly supported the notion that its function is the drying of contour feathers and not thermoregulation, balancing, intraspecific signaling or an aid to swallowing fish. However, the relation between the cormorant's feather structure, specifically its parameter, R+D/R, and this behavior has remained elusive and has been criticized by Alosin. However, the underlying issues have since been resolved in the light of new information that has become available since 1985. One of these issues was the necessity to select samples with only perfectly latched barbules with Rami parallel. Damaged regions will yield values for 2D that are too large and, consequently, values for R+D/R are too large. Unfortunately, these inaccuracies in the R+D/R values have introduced uncertainties large enough to negate a meaningful correlation between this parameter and species that do and do not wing spread. It is still possible, though, to draw a number of conclusions if only uncontested data are considered and if more recent data recorded with modern imaging software are included. Seabirds that regularly spread their wings include several species of cormorants, such as the reed cormorant, P. africanus, bank cormorant, P. neglectus, Cape cormorant, P. capensis, white-breasted cormorant and the double-crested cormorant, most of which have R+D/R values for their contour feathers between 4.3 and 4.9, Table 1. Families and species with parameters under about 4.2, such as the divers, 4.0, gannets, Sulidae, 3.8, auks, alcidae, 3.4, penguins, 2.3, and the Antarctic blue-eyed shag, P. atriceps, 3.8, never show wing spreading behavior. Pelicans, Pelicanidae, 4.9 to 5.4, including the brown pelican, 5.9, do so only very occasionally, but all other water birds do not with the notable exception of the darters, 10 to 11. Darters have contour feathers that promote water to penetrate to the skin in order to reduce their buoyancy, so they're very large. R+D/R value comes as no surprise. It is reasonable to assume that, with the exception of the darters, all water birds benefit from a plumage with good water repellency and equally good resistance to water penetration. However, as we have seen, the structural requirements for these two qualities are partly opposed, so it is to be expected that each family or species will have struck a balance that suits its specific demands of habitat and behavior. Spread wing postures can then be explained as being part of a behavioral pattern in those birds that dive frequently and therefore require good resistance to water penetration, but this resistance comes at the expense of a measure of water repellency, which is compensated for by wing drying. The question as to whether it is the wings or the body plumage that is being dried by wing spreading was raised by Sellers and can be addressed by considering the difference in R+D/R values between flight and contour feathers. Values for flight feathers, in particular the outer covers, measure 2 to 4 for both water and terrestrial birds, and these are therefore well protected from becoming waterlogged. Those for contour feathers, on the other hand, show much difference between these two groups of birds, with those of water birds that spend much time in the water and dive frequently ranging from about 2 to 4 and those of terrestrial birds ranging from about 7 to 10. Other water birds, including cormorants, have values that fall somewhere in between, Table 1. Contour feathers with R plus D/R values higher than about 4 are at risk of becoming waterlogged, which suggests that it is the exposed contour feathers rather than the flight feathers that need drying in cormorants and in darters. Apart from R plus D/R values, weather may also influence wing spreading behavior. Cormorants reduce the extent to which their wings are spread with increasing wind speed, and at speeds of 4 on the Beaufort scale sellers never saw birds to extend their wings more than about 50%. Wind speeds may also be the reason why spread wing postures are unknown in the Antarctic populations of the blue-eyed shag, but common in birds of this species breeding in Chile. The persistent strong winds at high latitudes may well be the cause for the absence of wing spreading behavior in the Antarctic populations. Other than wind speed, the relative temperatures of water and air may be a factor in wing spreading. A case in point is the flightless cormorant, P. harrisii, of the Galapagos, which is known to spread its stubby wings after a dive in the cool waters of the archipelago and, in this respect, behaves no different from other cormorants. However, whereas most other cormorants have contour feather with barb diameters between 48 and 54 m and R plus D/R values between 4.3 and 4.9, those for the flightless cormorant are 31 to 41 m and 7.1 to 7.4, respectively. These numbers suggest that the flightless cormorant suffers a measure of water penetration through the barbs of its contour feathers, a feature that is more reminiscent of darters than of cormorants. As with darters, increased water penetration is thought to assist the underwater bottom feeding habits of P. harrisii, for which too much buoyancy would prove to be a disadvantage. Simple calculations appear to support this notion. The pressure that a surface swimming flightless cormorant exerts on the water ranges between 630 and 780 Nm-2, whereas only 550 to 590 Nm-2 pressure is required to force water between the barbs. For other cormorants, the maximum weight for no water penetration between the barbs lies well above the bird's weight range. So, unlike those of other cormorants, the flightless cormorant's contour feathers are waterlogged after a dive in cold water, but the bird can then proceed to dry its plumage in the warm tropical breezes on the lava rocks, an advantage denied to cormorants inhabiting high latitudes.